Welcome back to The Deep Dive. I want to start today by taking you back to high school,
Oh boy.
specifically second period math class.
Okay, I'm there.
Remember that one specific type of student, the one who figured out that the answers to the odd-numbered problems?
We're printed right in the back of the textbook.
You're right. We've all been there.
I mean, I might have actually been that student on a, lazy Tuesday when I had other things to do.
Exactly, and the strategy is flawless for homework. You copy the number, you hand it in, you get the check mark.
Right.
But then the midterm comes around. The teacher hands out the test, there's no answer key, and suddenly you are staring at a quadratic equation with absolutely no idea how to move x to the other side.
Because you memorized the output, but you completely ignored the process.
Yep.
You know what the answer is, but not why it's the answer or how to get there.
Exactly. And that distinction between memorizing an answer and actually understanding the logic to derive it is really the centerpiece of our conversation today.
Only we aren't talking about high school slackers.
No, we are talking about the cutting edge of artificial intelligence. Today, we are digging into a really fascinating paper from Microsoft Research.
Yeah, it's titled Orca, Progressive Learning from Complex Explanation Traces of GPT-4.
And this paper is a really big deal in the AI community, right?
It's massive. It's tackling what I think is the single most expensive, most resource-intensive question in tech right now.
Which is?
Do we really need massive energy-sucking supercomputers to get smart AI? Or can we take a small model, and by small I mean roughly 13 billion parameters?
Which is something you could theoretically run on a high-end consumer laptop.
Exactly. Can we take that and teach it to think like a giant?
And just to set the stakes here for you listening, when we say giant versus small, we are talking about a massive difference in computational power and cost.
Oh, it's orders of magnitude. The giants, like GPT-4, are widely believed to be trillion parameter models.
Trillion with a T.
Trillion. Running them requires server farms the size of football fields. They consume enough electricity to power a small city.
Wow.
But the small models, like the one Orca is based on, which is Llama 13b, they are tiny by comparison. If Microsoft can make the small one act like the big one, it changes the economics of AI entirely.
It brings AI out of the cloud and onto your desk.
Exactly. It democratizes the whole thing.
That sounds like the holy grail.
Yeah.
But historically, that's been the problem, right? Small models have been, well, a bit disappointing.
Yeah, they try hard, but they usually fail the big tests.
And that brings us back to your math class analogy. The researchers identify a major flaw in how we've been training these smaller models up until now.
They call it the imitation trap.
The imitation trap. That sounds like a bad thriller movie. Let's unpack that. What exactly are these models imitating?
So recently, there's been a really common technique called instruction tuning. Basically, researchers take a small, dumb model, let's say Vicuna or Alpaca, and they want to make it smarter. So they treat a large foundation model, like ChatGPT or GPT-4, as the teacher.
So they feed the small model a question, show it the answer ChatGPT gave, and say, learn to write like this.
Right. If the question is, what is the capital of France, they show the small model Paris.
And the small model learns to associate the two.
Essentially, yes. They feed it thousands or even millions of these question-answer pairs, and on the surface, this seemed to be working.
The false promise.
Exactly. The paper calls it a false promise because the small model started producing text that looked incredible. The sentences were fluid, the tone was confident, the grammar is perfect.
But looking smart and being smart are two very different things. I mean, I can put on a lab coat and glasses, but you do not want me performing surgery on you.
Precisely. And the paper highlights a discrepancy that frankly shocked me. They asked GPT-4 to act as a judge.
Okay.
When GPT-4 evaluated the style of a small model like Vicuna, it said, "This is great. Vicuna is 92% as good as ChatGPT."
92%. I mean, if I'm a developer, I'm popping champagne. That sounds like you've solved it. It's an A-.
You would think so. But then they ran the same models on actual reasoning benchmarks.
Not just conversation.
Right. Specifically, a hard test suite called Big Bench Hard. These aren't creative writing prompts where you can bluff your way through. These are pure logic puzzles.
And how did Vicuna do?
Its performance plummeted. It was only 48% as capable as ChatGPT.
Whoa. So the style is 92%, but the actual brain power is less than half.
It's a facade. The small model had become a mimic. It learned the polite tone, the sentence structure, the cadence of a smart AI.
It was talking the talk, but it had no idea how to walk the walk.
He was the student copying the answers from the back of the book without learning the math. It could say, the answer's 42, confidently, but if you change the variable slightly, it would just fall apart.
That is a really dangerous place to be, especially if people are relying on these models for advice or coding or medical help.
Yeah, it sounds confident, so you trust it, but the logic underneath is totally hollow.
So this brings us to Orca. How did the Microsoft team solve this? How do you teach a model to stop mimicking and start actually thinking?
They flipped the script on the training data. Instead of just showing the model the answer, they used a method called explanation tuning.
Explanation tuning. I assume that means exactly what it says on the tin?
It does. In the old way simple instruction tuning, the training data is just a pair. Query and response. What is the capital of France? Paris.
Right.
Orca's data is much richer. It includes system instructions and explanation traces. They forced the teacher model GPT-4 to show its work.
So they aren't just saying, give me the answer. They are telling the teacher how to teach.
That's the key. The paper lists the specific prompts they injected into the training process to generate this data. They use commands like think step by step,
Go class.
or justify your steps. And my personal favorite, explain like I'm 5.
Explain like I'm 5. That was actually in the system prompts for a state-of-the-art AI.
It was. And think about why that works. If I ask you a complex question about quantum physics and say, give me the answer, you might give me a one-sentence formula, E equals mc squared.
Sure.
But if I say, explain it like I'm 5, you can't just give the formula, you have to break it down. You have to connect the concepts, use analogies, and lay out the logic sequentially.
You generate a lot more words. You have to tell a story about the logic.
And those words are the gold mine. That is the explanation trace. By training Orca on those long, detailed explanations, the model isn't just learning, the answer is 42.
It's learning the deductive path to get to 42.
It captures the logic, not just the final output. It's seeing the student's scratch pad, not just the final grade.
That makes total sense. It's shifting the focus from the destination to the journey. But surely you need a lot of data to do this. You can't just do this 5 times and expect the model to become a genius.
Right. And to do this effectively, they didn't just scrape a random collection of internet conversations. They built a very deliberate curriculum.
That brings us to progressive learning.
Yes, this is another area where the paper really shines. They used a massive set of tasks called the FLAN V2 collection, but they didn't just dump it all on the model at once.
I saw this in the notes. It looked like they used 2 different teachers.
They did. It's like the human education system. You don't start a first grader with a university professor teaching advanced calculus.
No, you start with a primary school teacher to get the basics down.
Exactly. So for phase 1, the primary school teacher was ChatGPT, specifically the GPT 3.5 turbo version.
Okay, so a slightly older, less complex model.
Right. They used about 5 million examples generated by ChatGPT. This is cheaper and faster to query, and it's great for building a foundation of general knowledge and conversational ability.
So the student model, Orca, spends phase 1 just listening to ChatGPT explain things.
Yep. Then, once it has that baseline, they graduate to the professor. For phase 2, they brought in the heavy hitter GPT-4.
The big guns.
They used about 1 million examples from GPT-4. These were specifically for complex reasoning tasks, and the data showed a huge difference between the 2 teachers.
In what way?
GPT-4's responses were, on average, 1.5 times longer than ChatGPT's.
Ah, so that extra length is the show your work part we talked about.
It is. That extra text contains the reasoning signal, the if this, then that logic that Orca needed to absorb. It's dense with causal links.
Okay, I really want to see this in action. The theory sounds great, teach it to think. But how do we know it actually worked?
The paper has some case studies that I thought were really revealing because they show the exact moment the other models fail and Orca succeeds.
Let's look at the Michael story. This is a temporal reasoning problem. It sounds like a logic puzzle you'd see on the LSAT or a brain teaser app.
Right. So here's the scenario given to the AI. You need to figure out when a guy named Michael could have visited the football field. You are given his schedule for the day.
Walk me through his day.
He wakes up at 10 a.m. He's taking photos at the Eiffel Tower from 12 p.m. to 2 p.m.
Nice.
He's at the movies from 2 p.m. to 4 p.m. He's visiting a rooftop bar from 4 p.m. to 8 p.m. And finally, the football field closes at 8 p.m.
Okay, so I'm doing the math in my head right now. He wakes up at 10. He's busy starting at 12, so 10 to 12 is free.
Right.
Then he's booked solid, 12 to 2, 2 to 4, 4 to 8, and the field closes at 8. So the only possible window is 10 a.m. to 12 p.m.
To a human, that's obvious. You see the timeline, you naturally visualize the blocks of time. But let's look at Vicuna, the model that mimics style but lacks substance.
How does Vicuna handle Michael's busy day?
Vicuna looks at the prompt and gets completely tangled. It says something like, well, the field closes at 8 p.m., so he couldn't go after 8 p.m.
True, but completely irrelevant. That doesn't tell us when he actually did go.
Then it somehow concludes that 10 a.m. to 12 p.m. is the answer, but the reasoning is garbled. Or in other runs, it hallucinates that he could go during the movie.
Lux.
It sees the numbers, but it doesn't understand the constraints. It's just keyword matching. It sees 10 a.m. in the text and thinks, maybe that's it.
It's guessing. It's literally throwing a dart at the timeline.
But Orca acts like a detective. In its output, it actually writes out the elimination process.
Oh.
Yeah, it says 12 to 2 is occupied by the tower, 2 to 4 is occupied by movies, 4 to 8 is occupied by the rooftop. After 8 is closed, therefore, the only remaining slot is 10 a.m. to 12 p.m.
That's a massive difference. It derived the answer rather than stumbling upon it. It literally showed the subtraction of time slots.
And here's another one that highlights the danger of shallow learning, and it's a bit more practical. The Bio-Olympiad question regarding rickets.
Oh, I remember this one from the sources, the vitamin D question. This one is tricky because it relies on real-world knowledge.
The question is, a woman has rickets, which is a vitamin D deficiency. Which food should she eat to help treat it?
Yeah, and the options.
The options are carrots, butter, whole grains, oranges, or tomatoes.
Now, if I'm just doing word association,
Yeah.
deficiency sounds like health.
Mm-hmm.
Oranges are healthy. Oranges have vitamins.
That is exactly what Vicuna does. And even ChatGPT struggled with this in early versions. They often guess oranges.
Because oranges are famous for vitamin C.
Exactly, and the model has a strong statistical association between vitamin deficiency and fruit or oranges. It's a shallow, keyword-based guess. It sees vitamin and grabs the most popular vitamin food it knows.
It's wrong, but it feels right if you aren't thinking deeply. It's a truthy answer.
Orca, however, breaks it down. It identifies that rickets equals vitamin D specifically. It scans the list. It knows carrots are vitamin A. It knows oranges are vitamin C.
Okay.
But it realizes that butter, while maybe not the healthiest food overall, does naturally contain small amounts of vitamin D. So logically, it is the best option on the provided list.
That is a very subtle distinction. It's not just picking the most popular healthy word. It's applying specific medical knowledge to the strict constraints of the question.
Correct. That is the power of explanation tuning. By forcing the teacher to explain why butter is the answer during training, Orca learned to look for the underlying nutrient content, not just the vibe of the words.
It learned that just because something is a fruit doesn't mean it cures everything. So we have the anecdotes, but we need the hard numbers. This deep dive isn't just about stories, it's about evidence. Does Orca actually compete with the big guys on the scoreboard?
The numbers are incredibly validating for this approach. On Big Bench Hard, that tough reasoning test we mentioned earlier, Orca outperforms Vicuna by over 100%.
Over 100%. That's not a marginal gain, that's a generational leap. Usually in AI papers you see, we improved by 3%.
I know, it literally doubles the performance. In fact, on Big Bench Hard, Orca reaches parity with ChatGPT.
Wait, let's pause there. You are saying a 13 billion parameter model is matching ChatGPT, which is likely over 175 billion parameters on complex reasoning tasks.
On that specific benchmark, yes, parity.
That is huge.
It proves that you don't necessarily need a bigger brain, you just need a better education. It suggests that a lot of the size in these giant models might be redundant if the training is efficient enough.
That's a game changer for efficiency.
Yeah.
What about the standard academic exams, the SATs, the SATs? Can Orca get into law school?
Here, the hierarchy is a bit clearer. GPT-4 is still the gold standard. It's way ahead. Orca definitely trails GPT-4.
Sure, that makes sense.
However, Orca beats Vicuna by 42% on average across these exams, SAT, LSAT, GRE, GMAT, and crucially, it retains about 88% of ChatGPT's quality on these tests.
So it's not beating the giants everywhere, but it's nipping at their heels. 88% of the performance for a fraction of the cost is a trade-off a lot of businesses would take.
Oh, absolutely. The paper specifically notes that Orca is particularly strong in entailment, which are logic puzzles, and semantic understanding, like catching sarcasm.
Catching sarcasm. That's hard for a lot of humans, let alone code. I have friends who still don't get my jokes.
It is hard. There's a task called snarks in the benchmark. You have to identify the sarcastic sentence between two nearly identical ones. Orca is surprisingly good at it.
How does explanation tuning help with sarcasm?
The researchers think this is because it learned from those detailed explanations where the teacher model pointed out why something was funny or ironic. It learned the nuance of tone, not just the dictionary definition of words.
That's amazing.
Like that?
We have to keep our feet on the ground here. This isn't a magic bullet, and we always want to give you, the listener, a completely balanced view.
Right.
Where does Orca stumble? What can't it do?
Well, it's still a smaller model, and small models have smaller hard drives, so to speak. Orca falls behind ChatGPT on world knowledge.
So, facts about the world.
Right. Things like pop culture, sports, or really specific trivia. There's a task called Ruin Names, where you change a letter in a movie or band name to make it funny.
Oh, I've played that game on Twitter.
Yeah, well, Orca struggles there compared to the giants. Just doesn't have the vast database of cultural references that a massive model has.
It's the smart student who spends all their time in the library and never watches TV. Ask it to reason through a math problem, it's great. Ask it who won the 1996 Super Bowl, and it might struggle.
That's a perfect way to put it. Also, we have to talk about hallucinations. We need to be very clear that Orca still makes things up.
Oh, right. The CV example stood out to me in the sources.
Yes. When they asked it to generate a resume or CV, Orca would just invent addresses, phone numbers, and emails.
Just totally fabricated.
Now, larger models do this too. They are creative engines, after all. But the smaller models can be particularly confident in their wrongness. It's better at the professional summary part, the writing, but the specific facts can be really shaky.
So definitely don't use it to fact-check your history paper without verifying.
Definitely not. But there is one area where the teaching method had a really positive side effect: safety.
You mentioned earlier that it learned from GPT-4, which has a lot of safety guardrails built in.
This is a fascinating ripple effect. They tested Orca on a benchmark called Toxygen. Yeah, it evaluates toxic content generation, hate speech, dangerous instructions, that sort of thing. Because Orca learned from GPT-4's explanations, which are usually very polite, balanced, and refused to generate hate speech. Orca inherited those traits.
It learned good manners by watching its teacher.
It did. When prompted with toxic inputs, it's significantly less likely to generate toxic content compared to Vicuna. It's a great example of how the quality of the training data, including those safety explanations, trickles down to the student model.
It didn't just learn logic. It learned values in a statistical sense.
Exactly.
So let's zoom out. What does this all mean for us? We have a model that is smaller, but smarter than its peers because it was taught to think, not just to parrot answers.
The big takeaway here is that we can actually distill intelligence. We used to think that to get better reasoning, we just needed to make the models bigger, more parameters, more chips, more energy.
The brute force approach.
Right. But Orca proves that if you change how you teach, if you use explanation tuning, you can pack a massive amount of that reasoning capability into a much smaller container.
Which has massive implications for cost and accessibility.
Huge. It means specialized, high-logic AI could run on a phone or on a local hospital server without needing to connect to a massive cloud data center. It democratizes access to smart AI.
You don't need $1 billion of infrastructure to have a model that can think through a complex problem.
Exactly. It puts the power of a supercomputer into a package that fits in your pocket.
It challenges that whole bigger's better narrative that has totally dominated Silicon Valley for the last few years. It's not about how big your brain is, it's about how well you use it.
It shifts the focus from quantity of parameters to quality of pedagogy, the quality of the teaching. It turns out teaching really matters.
Before we sign off, I want to leave you with a thought that struck me while reading this paper. We've spent this whole time talking about how AI learns better when it's forced to explain like I'm 5 or think step by step.
It's a very powerful concept for machines.
But it's not just for machines, is it? If an artificial intelligence, a complex matrix of math and code, learns deeper reasoning by breaking things down and explaining the why, what does that say about us? What does that say about the value of clear step-by-step explanations in our own learning?
It suggests that if you can't explain it simply, you probably don't understand it well enough.
Maybe we should all be acting a bit more like Orca and a bit less like the student memorizing the answer key.
I think we could all benefit from showing our work a little more often.
Absolutely. That's it for this deep dive into Orca. Thanks for exploring with us, and keep asking why.
Goodbye, everyone.